We're going on to section 4 of chapter 1, which deals with exponents, order of operations, variable expressions, and equations. Again, part of this is to help you with vocabulary. So in a sense, you need to know what these things are, and as we go on, we'll explain them. We're going to start off with a little introduction to exponential notation. Now, I think you're familiar with this sign. A dot halfway up indicates multiplication. So this is 2 times 2 times 2. And if we did it as we went, 2 times 2 is 4. 4 times 2 is 8. Now, a mathematical shortcut to illustrate this, or something like this, is to look at and say we have 2 as a factor because we're going to produce a product that indicates multiplication. We have the 2, 3 of them. So is there a way to write that in which you have 2 as a factor, but you're going to multiply that 2 3 times? And the answer is yes, and that is what exponential notation is all about. So it's written 2. 2 is your base, and you're going to take that 2 3 times. That then becomes your exponent. So we say 2 to the 3rd power is equal to 8. So these two expressions are equivalent. And you might say, well, where would you use this? Well, if you had a cube whose dimensions were 2 and 2 and 2, and you wanted to find volume, it's 2 times 2 times 2 gives you 8 cubic units. So there are 8 little cubes in here, all equal in dimension. Now you'll notice I've added the page number, which I forgot. We're on page 25 already. So as we look at these particular examples, first of all, we want to practice reading them. When you see something like this, you can say 3 squared, or you could also say 3 to the 2nd power. A special one for this one is 5 cubed, or 5 to the 3rd power. This one we don't have a special name. It's 2 to the 4th power. Now, this is sort of interesting. Normally, when you see a 7, there is no exponent there. But every number has an exponent of 1 written there. So this is 7 to the 1st power, but again, we don't write 7 to the 1st. It's assumed that it's there. And then if you have a fraction, like 3 over 7, and it's to the 2nd power or squared, keep in mind it's both terms. And here's one that I've added that you'll see a little later, 4 to the 0 power. Okay, so let's just do these. In A, 3 times 3 is 9. 5 times 5 is 25. Times 5 is 125. 2 to the 4th, we had 2 to the 3rd was 8. So 2 to the 4th is 16. Now, any power to the 1st power, any number to the 1st power is just a number. So that's going to be a 7. That's the European 7. For letter E, we're going to square the 3 and get 9, and square the 7. That gives us 49. Now you might think, can you cancel out these 9s? And the answer is no. And we'll get into that a little later. Now, they'll be showing us this later too, but I thought I'd introduce it here. 4 to the 0 power. Well, any number to the 0 power, and I'll give you the proof later, is 1. So again, they're not including that at this stage, but I thought I'd mention it. Going on, we're going to take a look at order of operations. Now, when we think of the word operations in mathematics, we're thinking of things like adding, subtracting, multiplying, dividing, taking the square root, taking the absolute value. These are operations. Raising something to a power. And many of you have heard this before. Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. And they use this as an acronym to help you remember the steps in the series of operations. The P stands for do parentheses, or grouping symbols first. Exponents. And again, these sort of go together. Then you're going to do multiplication or division as you go from left to right. Again, if division comes first, you do division first, even though it's in a second place here, sort of. And then again, addition, subtraction, in the order you come to from left to right. All of these are left to right. And the reason we have this is that if you did things in a different way, you'd get a different answer. Now, one of the things they use to help us limit having to make errors here is the idea of what we call grouping symbols. Now, what is a grouping symbol? Well, it's something to indicate that this is sort of together. And we start off, the most common are parentheses. Then brackets are used, braces are even used. And then we mentioned this earlier, the absolute sign is a grouping symbol. And this one too, the division bar. So that's one of the reasons whenever you write divisions or fractions, make the line horizontal. Sometimes you'll see a diagonal line because it's hard to put something horizontal if you're typing. But you want to do the division bar horizontally because it is a grouping symbol as well. And now we'll get on to doing some examples. Okay, we're on page 26, and now we're going to do some examples that are going to illustrate order of operations. So as we look at example A, going from left to right, we see a number divided by a number added to something that's raised to a power. Now there's no grouping symbols, but we do have an exponent. So we will do that, and this will then become 6 divided by 3 plus 25. We have done the exponent. Now they want us to do, again, from left to right, this division. So 6 divided by 3 is 2. 2 plus 25 equals 27. All right, in this one we have a number, division, a number divided by, multiplied by a number. So from left to right, we're going to do division first. So 30 divided by 5 is 6. 6 times 4 is 24. Now in number or letter C, we have our first symbol, a grouping symbol of a parenthesis. So we're going to do that first. That's going to give us a 15. And then we go 2 times 15 is 30. Well, maybe I left something out of C. I did. All right, I have to go back here. I did leave that out because I see the division sign there. Yeah, it's over the absolute value of 15. There you go. All right, so the top became 30. The absolute value of a negative 15 is a positive 15. And that just goes twice, so this equals 2. Now here it's 4 times a number raised to a power. So we do not do 3 times 4 first. What we do is we square the 4 first. And that'll give us then a 16. Then we go 3 times 16 is 48. Now notice if you did that other thing, which is wrong, you'd get like a 12 that you were going to square. That is absolutely wrong. Okay. Now for letter E, here we have a multiplication. So we do our multiplication first, and that gives us 3/4. Multiplying our numerator and multiplying our denominators, there's nothing we can cancel out. But now we have to convert the 1/2 into a common denominator of 4. So if you recall, we're going to multiply that by 2. So this then becomes a negative 2/4. So our final answer here, 3 minus 2 is 1/4. Looking at example 3, and they are going to get more complicated, but again we're using our basic rules. Let's do a little simplification. So absolute value, 4 minus 3 is 1. So this is going to become a 1 here. Exponent, this is going to become a 4. So now on our top we have 3 plus 1 plus 4. And our bottom is 3. So 3 plus 1 is 4 plus 4 is 8. 8/3. Now, just as a little review, this is an improper fraction. How do I make it a mixed number? Well, you divide the 3 into 8. That goes twice. And you have 2 left over. So 8/3 is 2 2/3. And to convert it back, you would go 3 times 2 is 6, plus 2 is 8 over your 3. In example 4, we're seeing a case now where grouping symbols, and usually the innermost grouping symbol would be a parenthesis. Then as you worked out, you would get to your brackets. So let's do the innermost. 10 minus 1. This is going to make this a 9. Then 2 times 9 is 18. So just review, this is a 9. 2 times 9 is 18. 18 plus 4 is going to be 22. And then we're going to times it by 3. This will give us a 66. And again, you're going to have lots of practice, but keep in mind, you do your parentheses, things that are inside grouping symbols, raised to exponents, multiply, divide as you get to them. If division is first, you do division, and the same applies to subtraction. The last thing you do is you're adding, subtracting. Order of operations. Example 5, again, the division bar, horizontal, is a grouping symbol. So as we go from left to right, the first thing we have is multiplication. So 2 times 3 is 6. 8 plus 6 is going to be a 14. Then we square the 2, that gives us a 4, minus 1 gives us a 3. And again, 14/3 is our answer. To put it into a improper fraction form, 3 goes into there 4 times, and there's 2 left over. So that would be the improper fraction. All right, we're on page 29 already, and we're looking at expressions, evaluating algebraic expressions, and we want to see what is an expression, and then what does it mean. Well, an algebraic expression is usually a combination of numbers, letters, grouping symbols, exponents, and these individually are called a term. These are all single terms, believe it or not. And we'll be going over that a little bit later as well. But what does it mean? Well, here we have 2x. This means really 2 times x. When there is no symbol between a number and a letter, it implies multiplication. And again, here's a number. This is a grouping symbol. It's a number before the grouping symbol. That means 5 times what's in the grouping symbol. Again, no symbol between a number and a parenthesis. It implies multiplication. Here, the same type of thing. 3 times whatever x is squared. And here, no symbol between them. It implies multiplication. A word that I just quickly mentioned when we talked about algebraic expressions is the word of variable. Now, what is a variable? Well, a variable is a letter that represents some value. Often we don't know in the beginning what that value is, but in algebra what we do is we go through a process to solve, to find what that variable would be in terms of a specific number. And we're going to do a lot of that in chapter 2. But here, what they want us to do is to evaluate in example 6, when we say the value of our x variable is 3, and our y value variable is 2. And what I'd like to do is show you a strategy for doing that, and this strategy is sort of important. So what I suggest is when you have something like this, put the variable in a parenthesis. Here our x is going to be 3, and it's minus our y. Since it's by itself, we can just put a 2 there. We don't need a parenthesis there. And for b, it's going to be 3 times 3 and 2 times 2. And all we're doing here at first is substituting a known value for a variable. So this would be 3 over 2 plus 2 over 2. Just substituting the variable with a known value. Now here, this is going to be 3 squared minus 2 squared. So all I've done is carefully substituted. Now there are little places where you can make an error, so that's where you need to be a little careful. But here it's pretty straightforward. 2 times 3 is 6. 6 minus 2 is 4. 3 times 3 is 9. 2 times 2 is 4. And notice you can't cancel. I looked at the text and they are leaving these answers as improper fractions. And then here, fortunately, we ended up with common denominators. So we just add our numerators and get 5 halves. And here 3 squared is 9, minus 4 squared is, 2 squared is 4, which gives us then a 5. Now notice here we're not squaring a negative 2. We're just squaring the 2. The negative is not included because there's no parentheses there or anything. We're just squaring the 2. That gave us a 4. Then we applied the negative sign. In example 7, and we are on page 30 actually, they're asking us to see if x were equal to 2, would this be a true equation? Now, by the way, so far we've talked about an expression, but once we put an equal sign somewhere in that expression, we're saying this expression on the left equals the expression on the right, and this becomes an equation. So let's just see what we get here. So this is going to be 3 times 2, x is 2, plus 10 equals 8 times 2. And this becomes 6 plus 10 equals 16, and 16 does equal 16, so this is true. You'll have some like that to do in your practice, and then later you'll quiz me. As we get into example 8, what they're going to ask you to do is to convert English statements into algebra. And in order to do this, you need to pick up on certain key words. Words for addition, subtraction, multiplication, division, and eventually an equation or an equality. So when we are reading something in English and you come across these words, and there are probably a few more, but these are the main ones. A sum, that implies addition. Plus, addition. Added to. More than. Increased to. Gives a total of. So again, these words used in some sort of sentence with values, you would put a plus sign between them. It indicates addition. All right, key words for subtraction. The difference of. Minus. Subtracted from. Less than. Decreased by. less. Again, all keywords for subtraction. Now, many of you have had these, throughout your life, but if English is your second language, you need to key in on these. Now, for multiplication, the word product. If you're going to get a product, you get to the product by multiplying. Times. Something times something. And then, of course, multiply is pretty straightforward. Twice. This implies 2 times something. And then the preposition of. 2/3 of 12. That means you're going to multiply 2/3 times 12. So of, particularly in that sense, 2/3 of something, you're multiplying. In division, we used this word before. This is a quotient that you're going to have a fraction, A over B. That's a quotient. To divide into 5 into 10. How many times? Twice. You're dividing. A ratio. That relates to the word quotient that we had the other day. And then, of course, divided. When you are setting up an equality, something is equal to something else. Well, the word equals, that's translated to an equal sign. Is, was, should be. These are all equal signs here. Yields, amounts to, represents, is the same as. Again, all of these things imply these operations. So when you're converting English into algebra, these are the key words. Now, I'm not going to do example 8 for you here, but you're going to have that experience as you do the practice and the quiz me. Well, I am going to do these. The sum of a number and 3. Well, let's say whenever we see the word number, we could use the letter X, and then they'll tell you what letter they want you to use. But I also like to use the letter N. N is for number. So remember, we can interchange these. The sum of a number and 3. Well, the key word here is sum, the number and 3. The product of 3 and a number. Again, the key word is product, which indicates multiplication. 3 and a number. We usually put the 3 first. Again, no sign between the two because that implies multiplication. Twice, this is one of the key words for multiplication. Twice a number. 10 decreased by a number. So this will be 10. Decrease is the key word for subtraction. Now, notice this is not n minus 10. The order in subtraction is critical. They're not reversible. We'll go over that a little later. But 10 decreased by a number. Now, if they had said a number decreased by 10, that would have been the other. But that's not what's here. Now, 5 times a number increased by 7. So 5 times a number increased by 7. Now, these are things that you build up through experience, and as you gain experience, you will get good at this. You'll need this for Chapter 2, and of course the rest of your algebra career. This will be the last example, and this is on page 31. Of course, reading the textbook is an excellent idea and will give you a few more pointers. This is just going over some of the main topics and seeing it done visually. Reading the textbook, that's your real Bible of this math course. Okay, 9a, the quotient of 15 and the number 14. Well, if you recall, we said a quotient is a ratio, and we put the first number on top and the second number on the bottom. That is the quotient, and it implies division. All right, 3 subtracted from 12 is a number. Now, here the order's a little tricky. You're going to subtract the 3 from the 12. So this will be 12 minus 3 translates to an equal sign. And the number, we're using the letter N. Your textbook is using X, by the way. So keep that in mind. They're interchangeable. 4 times a number. 4 times a number. Added to 17. Added to 17 is not equal. All right, that's a new thing. Is not equal is an equal sign with a line through it, 21. So here they're just asking you to put that in algebraic form. 4 times a number added to 17 is not equal to 21. Now these symbols are located in a tool palette in MathLab, and if you need more symbols, there's a little bar that says more. Click on that and that'll give you a lot more symbols that you could use. All right, another indication of multiplication is triple a number. So 3 times a number is less than, here they're looking for that inequality sign, 48. And they're not asking you to solve anything. They're just asking you to take English statements and convert them to algebra. Well, good luck. This is another section we've done. We'll go on to 1.5.